Hi, I'm Paul Battaglia, and this is section 1.5. I'm joined today by Gabe and Brittany. Welcome.
Thanks for having me.
One of the things they're going to talk to you about is the idea of how to approach this section from the standpoint of the teacher's perspective and almost dividing it into some of the more basic operations and the composite function itself. So, Gabe, why don't you start us off with some of those basic operations?
Okay. So while teaching adding, subtracting, multiplying, and dividing two functions, it's usually something that we can do pretty quickly, either in class, just as a review, or I can even show it to students through like a flipped classroom. So have them either read through the section on their own while they're at home, or find some resources available online and give those to the students and let them sort of learn how to add, subtract, multiply, and divide two functions. Because like I said, it's something that they should have seen before and they should be somewhat familiar with. Maybe just getting used to the notation again will help before we jump into composition of functions.
Right.
And I like to then have them do the decomposition of functions.
Okay.
And see where they're at with that.
Right, so they've composed them, and now we're asking them to basically look at a function that is really the byproduct of two functions having come together. And so what we're going to ask them to do then is we're going to ask them to split that function into two. And the great thing about it is there's really a lot of correct answers they could have. So we want them to be able to investigate, play a little bit, explore, not even be correct automatically, and then try and see how those functions fit into each other. Keep going, I'm sorry.
And then go into the actual notation of composition of functions, the F of G and everything.
Yeah, and I find a lot of times that students actually mistake that notation, that little circle there. They think that that's multiplication a lot. So do you guys have any idea on how to maybe make them not do that?
I'd like to take and just tell them to put a parenthesis everywhere they see that little circle or little dot. I'll tell them.
It gets them right into saying F of G of.
Yeah, and then it actually looks like, oh, I'm taking F, I'm substituting G into it for X. Right. And I think that really helps the students see what's going on. And
we see the decomposition of functions we actually will see down the road when we look at calculus. So students are always asking, two questions. When are we ever going to use this, and do I need to know this again, right? So, Brittany, you've just pointed out that we will see decomposition of functions again, and Gabe, I know you wanted to talk a little bit about that as well, right?
Yeah, decomposition of functions is something that's going to happen quite frequently in calculus. So we're going to see it when we're doing the chain rule, teaching the derivative. We're going to see it when we're doing U substitution, when we're integrating, and we'll see it plenty of other times throughout calculus. Even composition of functions comes up in calculus when computing derivatives, for instance.
Right. And I think one of the other things is, we answered that question now of that enduring, we're going to see it again, but when will we ever use this? This is a great section because you get to point out to students that they usually are experiencing composition of functions and they don't even realize it. So I know we've talked about the idea of, let's say a student goes into a store and there's 25% off an item, and they also have a $50 gift card. So talk a little bit about the order of the composition and things like that.
So that's something that's big about composition of functions, is that order does matter.
Right.
So F of G of X usually isn't the same thing as G of F of X. And taking it back to that example, if we're going into a store and we have a 25% off coupon and a $50 gift card, it matters which order those get applied in. So if you apply the gift card first and then you take off 25%, that might be different than taking 25% off and then applying the gift card.
Right. Along with that then, right, maybe the last thing to talk about when you compose functions is their domain, right? So Brittany, tell us a little bit about how we're going to get students to understand the idea of the domain when we take now two functions and combine them into one.
A lot of students want to just say, oh, I'll take the domain of F and the domain of G and just throw it all together. But as we know, that's not how it works. And so you kind of show the students, okay, what if we do that? What will happen?
Right.
And show them, let's plug in some of these values that you already have, made up that will not work, and show them, well, what do we do next? And kind of have them think about it.
Yeah, absolutely. I think these, again, great tips, and I think it can't be lost in here when we're talking in this section about, there is a lot of math going on here. However, if we have the opportunity to connect some prior concepts to some future concepts and some real world applications, I mean, you don't really get a better section than that, I hope these tips have been helpful and you have much success in section 1.5.